save you, okay? Hold on. I'm going to choose young lady. Would you come up?
Yeah.
Come up? Yeah. So I want you to take 2 or 3 like that. Hold it like this. Just have a seat for now. This young lady is next, and then I'll call you in a bit, okay? And then hold both hands like a steering wheel. There you go. Can I get you to back up a little bit? Come on back here. Come on back. Come on back. Don't be shy. Good looking behind you. Always good to look behind you. And face each other. Face your friend. What is your name?
What's your name?
Whale. Whale.
I almost heard it.
It's Lucy.
Is it Lucy? That's okay.
She's never been up. Maybe she has
That's
stage
That's okay. Well, hey, it's scary to me too. I'm just saying. All right. So then you're gonna hold. What is your name?
Mateo.
Mateo. I want you to hold both sides like that,
Nice.
like a steering wheel. Because I want you to hold it. Now I'm gonna have you back up a little bit. Uh-oh. And you are perfect. Don't change a thing. Now I want you to raise this up over your head. Both over your head. Okay. So now I'm going to use my slinky to talk about waves. Now, if I was in a bathtub and this would be my waves. If I just threw a splash in the bathtub, maybe I dropped a little bit of water, maybe threw some soap in the bathtub, what would happen? I made some ripples, right? Okay. Now watch what happens if I come down to this side. Watch what happens when the wave goes that way. This is a wave.
Whoa.
Just like a water wave, okay? Now, go ahead and hold it down for a second. Thank you very much. You may sit down. You may sit down, and please don't stand unless I call on you. Please. Thank you. All right, you can hold it down. Okay. So, when we talk about waves, we see this kind of thing all the time. When we are looking at water waves, when we hear sound waves, when we feel pressure waves, or maybe the wind is blowing to us. Now, waves always work the same way. You're doing great. Now, watch what happens when they speed up. They're going to change the frequency. They're going to make that frequency go up. No, that gets dangerous, right? All right, I'm going to step back a little bit. Change that frequency. Make it go as fast as you can. Fast, fast, fast. What happened to the frequency when they speeded up? The pitch went higher, and this is true. So, we notice a change in the pitch of the sound if we're listening to sound. To this bottle, a little bit, and then I'm going to shake the bottle up because I want to mix the liquid with the air that's in the bottle. Then mix it up. So I have to shake it a little bit, and then I'm trying to get the air mixed with the liquid. Because when I do that, I'm going to just real quick be absolutely sure I'm very careful and make sure I wipe off all the outside of the bottle. I don't want any fire on the outside of the bottle, but there's going to be some fire on the inside of the bottle. So yeah. Okay, so hold on. I gave away something. Where is my? Oh, here it is. Sometimes people get scared at this part of the show. You know what? That's perfectly fine. Don't worry. It does happen. Probably should happen.
No, I don't know what I'm going to do.
Are you okay?
Yes.
Because that was scary. I don't know about you. You saw what happened last time. It's not lighting.
When, like eating it?
I'm enjoying it.
Eat it.
This is a honey crisp. I like it really good. Now, if I wanted to share this, I would need
You're making an apple smoothie.
yeah, great.
It's apple water juice.
I left this honey crisp apple in my bag. It was in the car last night. So this warm temperature, like, wow, this is some sugar. It's really hit. Oh, no. Let's make it a purple apple smoothie, shall we?
Purple apple smoothie is gonna make you
Purple apple
invisible.
That'd be cool. Hey, let's look forward to that. I don't know, someone should be writing this stuff down. This is cool.
It's garbage.
Chemical energy, right? I used water and an apple, and now I could just drink it like this. Ooh, got lots of big chunks in it. It's not as sweet as it was when it was just the apple. But, so what I did was, I just put the apple in with a little water and just ground it up. And is this really great? Well, you can probably do better. But if you did like grapes, or you did like raspberries or blueberries or something like this, and maybe a little bit of cream, or like a little yogurt, sometimes it's really good with this kind of stuff. Amazing what you can get out of fruit. It's got a thing we're going to talk about. So first, the disco ball allows you to do this, okay? There you go. Come on, you try that. A little bit dancing is a good thing. There you go. Disco ball, disco ball. I wish I had my music now. Where's my music?
Eric, pick up your hand, Eric. Eric.
How is that possible? Okay.
Magic.
I gotta tell you a story about a guy by the name of Daniel Bernoulli. Now, he was a physicist. He lived in Switzerland about the same time that Benjamin Franklin was doing physics in the United States. And he was studying fluid dynamics. That is to say, what happens to fluids when they're in motion. And when we talk about fluids, he wasn't just thinking about liquids, he was thinking about air that moves like a fluid when it's moving really fast, which is kind of cool. Because if you think about it, I can feel that air coming out of the blow dryer, right? It's very, very blowing very hard. It's blowing so hard that when I put the ping pong ball on top. Now, Daniel Bernoulli did not have a blow dryer to work with, but he did discover this. He realized that when air is traveling very, very fast, it can't push very hard. But when air is very, very still, it pushes very hard. Watch. Air beside the ball is pushing very hard, right? How come the ball doesn't fly away? Because the air on top of the ball is higher pressure than the air on the side. And this is why it goes up, but doesn't stop going up. It's swinging around. You want to see this bigger? I can prove this. This is even bigger. The practical effect is this.
Ooh.
You hear something?
Crackling.
They always ask the same question. You know what this question is? Somebody knows. Go ahead. There was a man named Nikola Tesla. He was from Serbia. The Serbians are very proud of Nikola Tesla because he's a math nerd. And there's nothing like a math nerd to get you famous, okay? Because he was famous in Chicago. In 1893, they had a war. It was called the War of the Currents, and it was Nikola Tesla on one side and Thomas Edison on the other side. And you know what? Nikola Tesla won. And the reason why is Thomas Edison was kind of stuck in his thinking. He was thinking like DC was the way things, direct current. You know what we do the direct current now? This is direct current. So we can use this. It's very helpful, right? Do we want to run a whole city like this? Nah. Because you need really big copper wires, and it just doesn't work very well. But what Tesla did is he realized you could transform energy. You can make, that's the whole thing you do with energy. You can't start energy, you can't stop energy, but you can transform it from one form to the other. Remember, I transformed an apple into my body energy, right? So my physical energy. I transfer a little bit of chemicals into being able to determine, did we talk about this?
No.
I'm so sorry. I started off talking to my librarian about this. I bring, this is a piece of coffee filter paper with some pipe cleaner, and I use a special chemical called cobalt chloride. And the reason I make these, I do this in the chemistry class, but I bring it along for my physics class because humidity is an important thing. And when I'm in a room that has a lot of humidity, this flower is always pink because of the chemicals that I use. But when I use a blow dryer, I can get all of the water out of this flower, and look what happens to the color. Cobalt chloride is a very interesting chemical because when it's in the presence of water, you see that purplish pinkish color. But when there's no water around, like on a cold winter day, the flower turns blue. So I use this to determine how much humidity is in the room. If the flower is ever blue while I'm in here, then I think that there's enough energy that I can probably, there's enough humidity that I can probably get away with running my electrical equipment with no danger. But if I've got really pink flower and it just won't get blue, that means that it's so sticky in the room that you were kind of sweating, or maybe get a little shiny on my forehead like I was a minute ago, and that keeps this Van de Graaff generator from working because it requires a dry environment in order for it to work. Make sense? Okay, so now I said I was going to use something a little scarier, and that's this. But to do that, I'm going to need 2 volunteers. I'm going to choose people who, okay, I'm going to choose you, miss, I'd like you to come up. And I'd like you, miss, could you come up? Both of you ladies stand right here. Okay, and now this experiment, I'm going to use a different kind of a light bulb. So the light bulb that you see inside of my disco ball, it's like a little regular white light bulb, and it's got some color filters around it. This is a fluorescent light bulb. So these look like they're swords. Never swing these at yourself or anybody else because this glass is very delicate. And so I keep this in a mat case to make 100% sure that it doesn't bounce into things unnecessarily. Nikola Tesla invented wireless. Think about that for a second. You think about wireless, you think about your phone, you think about wireless communications, you think about the radio. He wasn't anywhere close to that. No, he was thinking bigger. He was thinking, no, we don't want to plug in something. We want to be able just to stand there and hold our device, and the energy is coming from the device, and it's filling our own personal device. So that's what he wanted, these giant towers that were energy stations. And he wanted this kind of thing, which is a wireless light, wireless energy. The light bulb, are we plugged in anywhere? No. Did you guys see that light up just now? Yes. Did it do it because these ladies are plugged into the wall? No. It did it because there's wireless, you see the little spark, and wireless energy is causing the spark, is causing the light bulb to light up. Aluminum foil. I use heavy duty because I just find it holds the shape a little better. So I'm going to put one of the round pieces of foil on top of my cup, and then I'm going to put the other piece of foil on top of my cup. So you see, it kind of looks like they're wearing hats. So I'm going to squish this down with my hand, and I'm going to squish this down with my hand. Then I'm going to re-squish that a little bit, it's kind of a little off center. I want to keep it pretty much centered. Now I have got 2 cups with a piece of foil on top, right? I'm almost done. I'm going to put 1 cup on top of the piece of foil over here, and I'm going to squish it down. So it's real flat. Flat inside the cup, curtain. And now I'm going to pull this cup out, okay, and then pull this around here. Do the same thing to the other piece of foil. I'm going to iron it kind of into the cup by squishing it down, making the foil kind of flat. We're in between the 2 cups. Now, I'm going to turn the whole thing right side up. So now I've got foil, cup, inside is empty. I'm going to use a flat piece of foil. I'm going to cut this myself. I'm going to drop it into the cup. I'm going to squish it in a little bit. I'm going to bend it over at the top. So I've got a place for the battery to attach, or the power to attach. I'm going to take the foil off the bottom, drop it in the top. And now I have cup, foil, cup, flat piece, and foil. This is a Leyden jar. This works. This will hold energy. Now, back in 1749, it was a lot of energy because they had a lightning bolt. The whole idea was we've been able to work these things, Franklin was thinking. But what we did back in the day, what they did then, is they had a piece of amber rod and a piece of fur, and they would rub the piece of amber rod with the fur, and it would cause a spark. Just like a winter time, if you touch a doorknob in the winter time, sometimes you get a little crackle. Feels like the Van de Graaff generator. Exactly the same thing is called static electricity. And this is a battery for static electricity. How do you charge it? Well, there's a number of ways. Back in the day, the old picture tube style televisions, the old fashioned with the big ones, you could actually do this one back. But these days, they don't really make picture tube televisions. Listen. You hear that? All of that rattling and crackling, that is a charge going into this. Does anybody want to try it? Stand. Everybody else is underfoot. Okay. Stand. Just barely touch. Barely. Did you get it?
Yeah.
It was a zap, wasn't it? Okay. I want you to capture a zap. You have to charge it every time. So capture a zap. Okay, now show it to somebody else. One finger only, just barely touch. One finger. Did it work? Okay, charge it every time. You gotta charge it every time. Okay, have a seat. Charge it. Very careful. Did you get a zap? Then go back again because you might have discharged. Okay. Good enough. Okay, now. Hey, what were you doing? But one at a time, don't fuss over it. You gotta touch. You gotta touch it.
En el aluminio,
Yeah, if you
Mateo,
can't touch
en el
it,
aluminio.
no, touch the foil. There you go. Well, it might have been, okay, so here, give it a try. Charge it, try it.